Okay, we're in second period recording, and we want to say get well soon to Dylan, Libby, and Avery.
Dylan and Avery aren't sick. They're just home playing Black Ops.
Ah, come on, surely. If you're at home playing Black Ops, you're in trouble.
I will find you.
Okay. All right, let's look back at number 5 real quick, just for a review. We are working on domain and range, and we know that the domain is the x values, range is y values. Our x values are also our independent variables, and our y values are our dependent variables. We found that this is a function. What kind of function is this? Is this a discrete or a continuous function? Discrete, because we have dots. Dots mean discrete. And it's only discrete because I said so. If it doesn't say so somewhere, then you can probably assume that it's continuous. I just wanted us to practice a discrete one. The next one we're going to practice is we're going to make it continuous. Okay? So when we find the domain and range, we just pull out the list of the x values, and that is our domain. Pull out the list of our y values, and that is our range. Now, where did we get these y values? How did we find them? We used the equation, and we plugged in x's. Where did we get these x's? We made them up. Okay? Any numbers can go in for x, because when you have a pattern and it is a function, any number plugged in as x will give you a y that is on that same line or series of dots, whatever we have. Okay, so let's look down at part B, and we're going to do the same thing. We're going to start out by making ourselves an XY table. Let's pick 0, 1, because I know what this is going to look like, so that's why I'm going to pick them. 0, 1, 2, how about -1, -2? And I just picked those at random, kind of, sort of. How can you square those? What's 0 squared? 0 minus 2 is? What's 1 squared? 1. What's 1 minus 2? -1. 2 squared? 4. 4 minus 2? Okay. -1 squared? No. That's good for y'all to remember that from the imaginary numbers. No, but -1 times a -1 is what? +1. A negative times a negative is a positive. Remember that? If the signs are alike when you multiply, the signs are positive. The final sign is positive. So a negative times a negative is a positive. So that's going to be +1 minus 2 is? Okay. -2 times a -2 is? +4. And that's 2. Okay, now, the best thing to do second is to draw whatever figure this makes. So we're going to do that now. At 0, my y is -2. At 1, my y is -1. At 2, x of 2, my y is 2. At -1, over here, did I do that right? -1 squared is 1, minus 2 is -1, yes. At -1, I have -1. And at -2, I have 2. So -2, I go up 2. Now this makes 1, 2. I put that one too high. This makes a shape that we will talk about later. It's called a parabola. And what it looks like, I'm going to go ahead and connect the dots. We're going to call this one continuous. And so those continue on forever and ever in that direction. Now, is this a function? Yes. Okay, this is going to be review from a couple of days ago, probably back Thursday. What is our domain for this one? All of our x values that are possible. And that's these. All right, yeah, it's the all real numbers. Okay, because these lines, as they continue to grow out this way and this way, they're going to include everything on the x-axis forever and ever, amen. So all real numbers, if you can't remember that, write all real numbers. Either one of those, be familiar with. Okay, now, what about the range? And be careful here with the range. Think about it. Yeah. All real numbers over -2. Does it include -2? There you go. So y is greater than or equal to -2. That's the mathy way of saying it. And this is what you'll see, this type of thing. But you said it right in words. All real numbers greater than -2, including -2. Okay, so you can't go down here anymore because it turns around and makes a U-turn. Okay, good job on that. Let's flip over and see what we've got over here. Okay, I'm going to stop with that for now. And I have a worksheet that I'm going to pass out. In fact, I'm going to hand this to somebody to pass out so I can keep talking. That's way too many, but just make sure everybody gets one. Here's what's coming to you. This is just a bunch of graphs. I think I showed that. Did we even look at it yesterday? No. Okay. Some classes got to glance at it, some did not. You will have some of these on the test.
Wait.
Is it? Okay, go ahead and get him another one. That was the one I was writing on.
I'll take it.
Yeah, Okay, we're going to be able to name the domain and the range on these. And what I've done is I've put solid dots where that function ends. And I've put arrows to show you that it continues. I did not give you any open dots, but what does that open dot mean? You name that point, but it's not equal to that point. It's greater than or less than that point. Okay, even if something is not a function, it can have a domain and range. All right? Let's look at this. Thank you. Let's look at this first one together. I'll do a couple of them. And there's not a lot of room to write here, so if you want to put the domain on top and the range on bottom, that's fine with me. You're going to finish this up on your own today and turn it in before you leave. We've got plenty of time. But I will start by doing the first two. How about that? All right, the first one, the domain. Got all that good stuff there. They said yesterday, if you turned it this way, it looks like screaming unibrow man.
That's upside down. Where?
Screaming unibrow man.
I can make a French dude out of the signs.
It does.
Okay, so screaming unibrow man is our domain. So what is it? X is going to be between 2 points, isn't it? So remember, we put our X in the middle. Since it's between two things, let's name what it's between and start with the low end or the left end. Okay, let's look. Right here is our outer limit, our low limit. Here's our high limit. I think you're close. This is 1, 2, 3. So it's going to be between -3 and positive 1, 2, 3, 4. Okay, so what signs go in there now? Okay? I'm going to make the greater sign point to the x, since the domain is going to be greater than this. So greater than or equal to. And then on the other side, it's going to be less than or equal to this number because it's this area in here. So it's less than or equal to. Here's a little trick. If you go from left to right on your number line, your signs are always going to be facing this way. Okay.
Wait, doesn't it greater than though? Greater number, doesn't it always face toward that number though?
Yeah, whichever one's greater, it's fake. Okay, right here, the x values, the domain is greater than -3 because these numbers are greater than -3, right? And then x is less than or equal to 4. It's because it's this way. Yeah, it's a compound inequality. And if you're not used to reading them, it's kind of weird. But read everything in terms of x. Read it this way for that and this way for that. Okay? Yes, Connor? No, only if these are filled in. If that had been an open dot like that, you would not have put the equal sign because it doesn't include that point. It just goes to that point. Yes? Okay. Everything is in terms of x because we're talking about the domain numbers, right? And it's going to be, and I'm going to use the word range loosely here because I'm not talking about the range like the y values, but the range of the domain, the low end and the high end. If you line it up where this number is here, then you put your x, because it's in between those two numbers, and then there's your 4. Now read it in terms of x. X is greater than, so the greater sign has to be facing the x, the big part, because your x's are in here that you're looking for, your domain numbers are between these two, and the values of interest are from here to here, right, or from here to here in the x, so they're greater than the -3. This is -2, -1, 0. Those are the numbers that are greater than -3. And then these right here, this is the top range. So this area includes the numbers less than 4. Because this is 3, 2, 1, 0. Well, it depends on which way you're going. Okay, let me try again. I'm going to erase this so we can see what we're doing. I've drawn on this way too much. Okay. Let me start over. What area, okay, on the x's, what area are you interested in? What area includes the domain? This is your lowest x value of -1, 2, 3. This is your highest x value of 4. Okay. Now the area that you want to name is in between these two. That's your x. X is between those. So is this area right here less than -3 or greater than -3? Are the numbers in that area higher than -3 or lower? They're higher. So this area is greater than -3. Does that make sense? I knew that was going to come on in just a second. Yeah, because you're looking for this area of x's. Now, what area of y's are you looking for? Well, we've got to do our range next, so let's go ahead and see. Your highest y is here. Your lowest y value is here. So now you've got to name this area right there. That's the range. So what's the range going to be? So it's y now. Don't put x in there. Remember, keep your x and y straight. So it's all your y's between who and who? Okay, which one are you going to put on this side? I'm going to put the -3. I want my lower numbers on the left. Okay, so 1, 2, 3. So -3. And then my highest number is going to be 2. Okay, and they're both going to be equal to, because these are blacked in. So the y is greater than the -3. So make the big part go to the y. And it's less than the 2. So make the little part go to the y and the big part go to the 2. There. So your range is all y values greater than or equal to -3 and less than or equal to +2. Is that making sense? It's going to take practice. Let's do one more together. This circle, because the circle is kind of intimidating. Same thing, okay? Your domain